I've been kind of lagging behind on the structural research videos. That was the next set of videos I was going to do. I have been working on the project, but nothing that's been like update worthy. But I decided I'll go ahead and make a video just real quick of the kind of what I'm thinking for the structure. Right here you can see just some notes that I had before I found out that I calculated the downforce incorrectly. So these aren't really valid. I just kind of sketched out some concepts. These are just some parts that I thought we were going to use. This was an idea I had to kind of balance the force on the airfoil, so the stress on the motor was minimized as much as possible. There's a couple different solutions to that. We can run a rod along the center of pressure of the airfoil. That may be more difficult to calculate since it is a curved airfoil and it's not a constant curve. I used a spline in the Fusion 360 to model the curve here, so I'm not really sure how to calculate that. I know you can, if you have the coefficient of pressure over each differential piece of the wing, you can integrate over that, blah, 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 blah. But since we don't have an equation that defines the curvature of the wing, I'm not 100% certain. And with X-foil, I'm not sure if there's a way to output the coefficient of pressure or the total coefficient of pressure, considering the bottom and the top of the airfoil. I'm not sure if I can output that from X-foil. This might be a little bit of trial and error. We'll see. So here's the actual airfoil. I'm modeling it in halves. So here is would be the right-hand side because I modeled it upside down. Well, upside up, but a car airfoil that generates downforce is upside down. So here's that. Here's kind of what the spar will look like. I've done some redesign with that, and I haven't decided if I'm going to use a forged carbon fiber spar or if I'm going to use an ABS spar. I'm leaning toward forged carbon fiber just because it'll be more resistant to heat, and since it's not 3D printed, there's no risk of it delaminating and deforming. But I need to kind of nail down how I'm going to do that. I am kind of thinking about doing the spar in halves and then sandwiching it on an aluminum piece like this right here that will hold the what are they called, tie rod ends. So I think that would be a good combination of strength and modularity and ease of assembly and ease of manufacturability. So that's kind of where I'm at on the spars. This gets into what I've been working on more recently. I wanted to build a smaller part that still allowed me to use what I'm practicing with. So I decided to make a mold for front canards. I don't know if you can hear that, but my printer just finished printing the last piece of Canard. Actually, let me show you. Voila! This is the last piece of the mold for the Canard. So this is for this page right here, what I was kind of working on. And so this is the full carbon fiber mold for the front Canard. It is kind of big. But anyway, what I plan on doing with this is sanding down the layer lines and then applying several generous coats of release wax, and I'm vacuum bagging it. One thing that I didn't think of when I was modeling this was the sharp angles in the corners. So this is kind of the outside wall that keeps the higher pressure air from looping over. Close to the end of the Canard, I will probably sand down this wall to allow the high pressure air to loop over and create that vortice that will enhance adhesion of the boundary layer to the side of the car. But also the other right angle on the side that mounts to the car, I don't think the carbon fiber will be able to bend over it at that sharp of an angle. So I might sand just a little kind of fillet on this edge. It has a better chance of staying in the proper shape, but that's something I'm going to do. I'm going to start working on as soon as I finish this video. But that's where we're at on this part of the project. So for the structure, I wanted to have a little experiment that I could use if it turned out well. I didn't want to waste my time, mold something and create something and spend like 15 hours of 3D printing and several hours of, actually doing the layup, and then just have this knickknack that I didn't use. So I decided to go with front canards. This is sort of the profile that I followed. I ended up going a little shallower, and it extends out to here. I may not do that full profile. I may cut it down a little smaller. It'll really just depend on, let's be honest, how it looks on the car. I don't want it to look ugly. Let's see. This is just the idea that I mentioned earlier about making the spar out of ABS with the sandwiched aluminum plate that holds the tie rod ends. But I'm kind of going back to forged carbon. I don't think it'll be that much weight savings, but it will be stronger and it'll be more resilient in the hot and cold. Thinking of the life of the airfoil, I want it to be, resilient and last a really long time, obviously. I don't want it to be something that, breaks in a few years if you have to park it outside. So I do park mine in the garage. Fortunately, I'm able to do that. I would like to maintain that resiliency and longevity. So I was coming up with some ideas on how to integrate the actuation of the airfoil. So the center of rotation will be about here for, this kind of mock-up concept design. And originally I was thinking about actuating the rear point, just because I don't know why I assume that's how most airfoils work, or active aero works. If I put the actuation on the front mounting point, it allows a more vertical actuation, and so that will make it easier and give the most mechanical advantage to the motor. So I think I'm going to design the airfoil like this, where it has the hard mount on the rear pivot point and the actuation point will be on the front. And since the mounting points are about halfway out on the wing, my thought process is it should average out as far as the center of pressure on the front and back of the wing. So I'm really trying to keep in mind the amount of force that the motor will have to output, because the less stress that the motor is under, the longer it will last and the faster it can actuate. So that's really something I'm trying to keep in mind. I've found a couple motors and a couple gearboxes that I think will do a really good job. And then this was I was just trying to identify symmetrical reference points to draw the wing if I was going to do a curved wing. I don't think I will. It'll probably be at the point of these 2 points. That's where it'll be centered on, and it'll just be a flat wing. I'm like, in future versions, I may do a slight curve to kind of go along with the airflow along the surface of the car. I think I'm just trying to think of the airflow in my mind. So the farther away from the body you get, the more laminar the flow. So if you make it curved, outside portions of the wing will be closer to the body in dirtier air, but the top will be in cleaner air. However, if you make it flat, I feel like that cancels out because the middle will be in slightly dirtier air, but the outer corners will be in cleaner air. And I think the outer corners will be cleaner with a flat wing than the center will be with a curved wing. So I think making it flat is a good trade-off, especially when you think about when you need downforce, it's in the corners and you want it to be on the inside. And if you're curving around, the air inside, hold on, will the air inside be cleaner? I don't think it will be. But keeping the wing flat will still be, the outside will still be cleaner airflow than if it was curved. And you want the downforce on the inside tire. So yeah, I think making it flat is the best option. Also, making it curved means that the airflow won't flow straight front to back. It will take the path of least resistance, and it might, flow up, which increases the velocity on the bottom of the foil, which means, no, does it increase the velocity? I don't know. I'll have to think about this some more, but it's something I'm playing with. I'm trying to decide which is the best way to do it. And then these are just some wings that I was looking at, like, you know, how they do it, and trying to get some inspiration. One thing that I've noticed about a lot of these is this structure here isn't covered with anything. What I would like to do with mine is cover this with a symmetrical airfoil to decrease drag as much as possible. One thing that, I mean, we just have to, where'd it go? There we go. One thing that I am really trying to keep in mind is I'm designing this for a lower power car. So drag is a major consideration to the way I want to design this. With all that out of the way, I'm going to take these out to the garage, try to remove these layer lines, and then I'm going to super glue them together. I'm going to prep them with mold release. I think this is wax, but prep them with mold release. Then, let's see, what's the next step after that? I think it's applying the epoxy, putting down a couple layers of carbon fiber. So I got the starter kit from Rock West Composites. I've been looking at tutorials from Easy Composites. They're UK based and the shipping was way more if you get it from the US. So I would recommend Easy Composites tutorials. They have a great learning section. Easy Composites, if you ever see this, I'm sorry I didn't order from you, but shipping to the US is way more expensive and it takes way longer. So if you ever get a US warehouse, let me know. But I got a starter kit from Rock West Composites, and it came with everything you need to make your first part minus the mold. You'll have to come up with the mold for whatever you want to make yourself. They do have a smaller starter kit that comes with like a NACA air duct mold that you can use to just kind of get a feel for what you're doing. But I wanted to go with a larger starter kit because I wanted to make actual functional parts right off the bat, just in case my first iteration went well and I'd be able to actually use them. I think this is a fiberglass fabric. So you get 1 yard of this fabric, but it's 58-inch width. So plenty to do several canards, probably 3 or 4 sets of them. And this is the carbon fiber.
Carbon fiber, carbon fiber, carbon fiber.
Can't wait to use this stuff. This looks so sexy. This also comes in the large starter kit, 1 yard of this material, but it is a 58-inch width as well. So quite a bit of fabric, plenty to do. Several iterations of something like a Canard or smaller Aero piece for your car. So that's the plan now. The print just finished. I've got the mold. I've got the vacuum bagging supplies, the vacuum pump, bag, peel ply, leader cloth, resin trap just in case. I don't think I need one since I'm not doing resin infusion, but I got one just in case to protect the pump. And of course the epoxy, the hardener, the mixing doodads, and all that. So without further ado, let's head out to the garage and start working on the fun bits.